So notice that I've reproduced the sketch that the narrator was just going through for the possums, only I have scaled it and added the z-axis in the way that you are expected to do if you were to do this problem. And I've also gone ahead and reproduced the work that the narrator had done in finding the z-score. So the next thing that we need to do is we need to find the probability that x is less than 98 millimeters, which is, as we now know, exactly equivalent to finding the probability that the z-score is less than 1.5. I will now go ahead and show how to do that using RGuru. So let's see how we would use RGuru to find the probability, that is the area under the curve, for all values of z less than 1.5. So I start by left-clicking on probability simulation, left-click on probability. I come over to probability calculator, left-click on continuous, and I see a dialog box pop up. We don't need to worry about naming our calculations, so I'm not going to worry about that. Do make sure your radio button for values, that is, in this case, z-score values corresponding to probability, that is, area under the curve, is checked. Just as an aside, notice that the distribution is already in my RGuru preset to normal, but there is a drop-down menu that has a variety of different continuous distributions that we can find probability values for. The next thing to make sure of is that the mean is set to 0, because in our class we are always corresponding probabilities to standard normal distribution curve, which has a mean of 0 and standard deviation of 1. And then the last thing we need to fill in is what z-score we want to find the area under the curve for values less than our given z-score, which in this case is below. Notice if I click on that drop-down menu, I can also find the area under the curve for values above this z-score or between two different z-scores, and we'll see examples of those pretty soon. Okay, so everything's filled in. I now hit preview. Notice that the dialog box value has now changed to 9,332 10,000ths rounded to 4 decimal places. In this class, we always round our probability values, or also known as proportion values, to 4 decimal places.